Hi, I'm Perrin.
G'day, and I'm Rory.
Hi, I'm Anon.
We're here today to talk about the model that we've developed for the assignments, which has the intention of locating a potential new ski field area within the Canterbury region. The purpose of this is to firstly bring some more snow sport tourism into Canterbury, and secondly to find new locations for ski fields that will be more resistant to the effects of climate change. Factors that were considered within this model were orientated around south-facing slopes, which will receive more annual snowfall and retain it for longer periods within the ski season, and optimum elevation for snowfall and the precipitation levels. Before our model was created, several assumptions were made to ensure the simplicity and viability of our developed model. These are as follows. We assume that any precipitation at elevations higher or equal to 1600 metres will automatically be snowfall over the ski season, which is around about May and October. We are also assuming that the permanent snow line during the winter is at 1600 metres above sea level. We're assuming that southern aspects receive more snowfall during winter storms and experience less snowmelt than northern aspects. Precipitation data used from last year's ski season is also reflective of future years to come. Our last assumption was that the identified ski areas were assumed to have adequate slopes.
To find ideal ski locations in the Mount Hutt and Craigieburn ranges, we produced a model on ArcGIS, which has two different parts. So the first part makes use of 6 different tools and 2 different inputs, being contour data and a digital elevation model. And this produces an aspect map for the areas. And then the second part involves 2 data inputs, one being a precipitation layer taken from Canterbury maps, and then data taken from rainfall monitoring stations for these different locations to be put through 3 different tools and map the precipitation of these areas. Because we're assuming that all precipitation that falls at 1600 metres or higher elevation will fall as snow, we use the Select Layer by Attribute tool on both the contour data sets to filter out all the contours below this elevation of interest. The Export Features tool was then used to create 2 new data sets containing only the contours of interest. The Feature Polygon tool was then applied to create polygons for each of the contours areas above 1600 metres elevation, and this was applied to the Clip Raster tool with the digital elevation models for each of the respective areas as the input, and then the corresponding polygons as the output extent. When running this tool, it was ensured that the input features were used for the clipping geometry. The Aspect tool was then applied to create orientation profiles for each of the ranges, and it was reclassified so that south-facing slopes, which experience less snow melt and more snow supply in the winter, would have a higher value of 5 or 6, and then all other orientations would have lower values. A map of rainfall monitoring locations in the Canterbury region was sourced from Canterbury Maps, to which the average rainfall data collected in the previous step was joined using the Add Join tool. The Inverse Distance Weighted tool was then used to create a raster map of the average precipitations for the areas of interest, using the rainfall section as the Z value and specifying an output cell size of 25 so that it would match the aspect maps produced for both the areas. The Reclassify tool was then used on this raster to give higher weighting to areas of higher average rainfall. Average rainfall data for the areas of interest was sourced from Environment Canterbury, and values were taken for the period between the 6th of May 2024 and the 31st of October 2024. The main reason for using this period is because the model's intended use is to identify ideal ski locations to be used during the May to October period and isn't so concerned about the rainfall data for the summer months. The values were then put into an Excel spreadsheet with the corresponding locations and was uploaded to the ArcGIS document as a CSV file. Finally, the raster calculator tool was used for both the areas, multiplying the reclassified aspect map to the reclassified precipitation map. Areas with better or higher precipitation values and better aspects were shown with a green symbology, whereas lower precipitation and worse aspects for ski fields was shown as red. The final two maps produced highlighted ideal ski field locations.
Sweet, so the outputs of our model were two regions that we used. One was the Mount Hutt, Mount Taylor and Palmer Range area, and another one was the Craigieburn Range. For the Mount Hutt area, our model identified several promising locations for a new ski field. The main one being on the northern edge of the modelled area. This was in the Palmer Range. Our model also showed that Mount Taylor, kind of the bottom left group of mountains, had huge potential for a ski area if the precipitation was good. You can see in the map that there is quite a large amount of area lying above 1,600 metres elevation. It's just a shame that the precipitation let it down in this regard. Our model also picked out the Mount Hutt ski field as being an okay ski area. According to our model, the region identified in the northern part of our map as the ideal location for a new ski field seems way better than Mount Hutt does, but Mount Hutt is an existing ski field and hugely successful. In the Craigieburn region, our model again picked out all the existing ski fields as good places to have them, but the only really good existing ski field that sits above 1,600 metres elevation and experiences sufficient amounts of precipitation throughout the year was Mount Olympus. All the other ski fields in the region were identified in our model as being potential locations for ski field, but pretty average ones. Our model also picked up on a new location for a ski field in the Grey Range behind the main Craigieburn Range, which shows heaps of potential for a new ski field, being completely above 1,600 metres and experience sufficient precipitation levels throughout the season. All in all, it's safe to say that our model worked really well to find a new location for a ski field, as it identified all existing ski field regions and gave us a good idea of where new ones could be. In fact, finding better areas than existing ski fields in the regions. Some limitations of our model include that the model identifies all south-facing aspects of mountains ranges, even when they may be convex slopes and when they are too steep for practical installation of ski lifts and infrastructure. Another limitation of our model was the output areas identified, or the areas identified were pretty broad, widespread, so it would require manual inspection to identify better areas than those just picked up broadly in our model. Further limitations include our model does not account for the gradient of the terrain within identified areas. The model does not take into account the accessibility of new areas, so to put roads in, no buffer around the areas was created by our model, and the model is, the feasibility of new ski areas is all subjective to the scoring system that was produced by us.
So moving on to the environmental ramifications, if this model proposed ski field was used as a viable option and undergoes construction, there would inevitably be several environmental impacts on the alpine ecosystem. These will include soil disturbances from earthworks and road and infrastructure construction, the reduction in alpine flora and fauna, and an increase in human activities around that area. Climate change also has influence on ski fields based upon their effectiveness of holding onto snow. To account for such a thing, the focus of using south-facing slopes will be advantageous to other surrounding ski fields that may not have this as a consideration. This will mean theoretically that our proposed ski field should last longer not only during the ski season, but also will continue to hold the most promising snow compared to other fields. Prior to all this, it is recommended for an environmental impact assessment to be carried out, which aims to address, avoid, and offset any potential adverse or costly changes to the environment in regards to the development of this proposed ski field. Moving on to future potential improvements with the model, we would incorporate buffer zones set to around 15 kilometres radius to ascertain whether the areas identified as feasible for development of a ski field will fall within a reasonable access distance. This distance is the maximum acceptable distance based on the Mount Hutt access road being 15 kilometres long. This is the longest in Canterbury region and is the second longest in the country from ski field to main road after Rainbow Ski Field. Additionally, factoring in slope steepness will also be something to account for. This is to ensure a range of terrain which is best suited for not just one ability level. This can be developed within the model itself and will show us these things.
In conclusion, our model was pretty good. It worked well. It managed to identify 2 valid potential new areas for ski fields. We can say that this is correct because our model also identified existing ski areas such as Mount Hutt, Mount Olympus and the Craigieburn Clubbies. Further inspections and site accessibility investigations will make this new ski field become a reality.